Okay, so we're going to talk about secants. A secant, first of all, let's talk about what it is a line that intersects a circle in exactly 2 points. It's a line that contains a chord. So if I just look at the chord for a moment, we already talked about what a chord is. So right here, from there to there, from endpoint to endpoint of the line segment, that's a chord. So if I just extend that chord, that's what's called a secant. So it is a line that contains a chord. Now, sometimes a secant will be, rather than a line, it might just be a line segment. It still contains the chord, but then keeps going, and we just have that line segment. So we call that a secant segment. Okay, so that's what it is. Now let's take a look at some things we know about secants. So if I have, looking at this diagram here, if I have 2 secants, those you can see are intersecting at this point that's outside the circle, point P. So if I have 2 secants that are intersecting, we actually know something about the angle that's created where the secants intersect, angle P. So what we know is that the angle is half of the difference between the larger arc and the smaller arc. So those 2 arcs are created from where the secants intersect. So if I take the measure of the larger arc and I subtract the measure of the smaller arc, and I divide that by 2 or multiply by 1/2, I'm going to get the measure of the angle there that's outside of the circle. So that's the theorem, that's the formula that we're going to use. Let's take a look at how we would use that in this first example. So I know that the angle, which is x, is equal to half the difference between the larger arc, 146, and the smaller arc, which is 54. So that's half of, if I have 146 and I subtract, if I have 146 and I subtract 54, that gives me 92. So half of 92, or 92 divided by 2, is 46. So x is 46 degrees. Taking a look at this other example here. So again, I do have 2 secants that are intersecting outside of the circle. So I'm going to say that the angle measure, which is 25 degrees, is equal to half of the larger arc measure, 133, minus the smaller arc measure, which is x. So I'm going to trying to solve that to get rid of 1/2. I'm going to multiply both sides by 2. So when I multiply by 2 on the right, the 2 times the 1/2 is just 1. So I'm left with 133 minus x. And I multiplied by 2 on the left and got 50 degrees. So I have 133 minus x equals 50. So I'm going to add x to both sides and subtract 50. And that gives me, so I have a 133 and I'm subtracting 50 from each side, which gives me 83 degrees. So x measures, the arc there measures 83 degrees. Okay, so that was secant, 2 secants intersecting, and we were looking at the angle measure. Now let's take a look at the segment length. So for secants. So this formula is similar, well, first of all, in words, the product of the length of the entire secant segment and its external part is equal to the product of the other secant segment and its external part. So that's what it is in words. Let's take a look at it using a formula. This is similar to the chord length. However, with the chord length, remember we looked at piece times piece was equal to the other piece times piece. Here, PQ is the external piece, but it's times not the internal piece, it's times the whole entire, let's put it up here, it's the whole entire length of the secant. And same thing, that's equal to PS, which is the external part, times the whole entire length of PT. So let's see how we use that with example number 1. So I want the external piece, so 12 times the whole entire length is 27, should be equal to the external piece, which is X, times the whole entire length, which is 30. So I'm going to do 27 times 12. So let me figure out what that equals. 12 times 27 is equal to 324, is equal to 30x. So I'm going to divide both sides by 30, and that gives me 10.8. Okay, so we have 10.8 units is the length of x. Okay, let's try that in our last example here. So again, the external piece, give myself some room. So the external piece is 10 times the whole entire length of the secant. Be careful there. So it's not 10 times 8. It's 10 times 8 plus 10, which is 18. Should be equal to 9 is the external part times the whole entire length, which is going to be 9 plus x, the quantity of 9 plus x. Okay, so let's go ahead and solve that for x. So 10 times 18 is 180. I'm going to distribute the 9 to the 9 and get 81. And 9 times x is 9x. So I'm going to subtract 81 from each side. And when I do that, I'm getting 99 is equal to 9x, which means x is equal to 11. And that would be units, because we're talking about length here. So 11 units is the length of x. Okay, now I'd like you to give these a try. Page 17, 2 and 5, page 27, 28, numbers 2 and 3. Please work on those now.